Okay, so an example of a vector space that we talked about last time might not have been this exact one, but it was very similar to it, okay? Okay, well, in R2, how would you graph the set of ordered pairs such that x equals 2y?
Divide by 2, and then just graph y equal to 1/2 x.
Yeah, it's y equals 1/2 x, which is a straight line through the origin with slope 1/2, right? Okay? Now this is a vector space. That we, again, proved it for some other, probably some other relationship, but there's another line through the origin. Any line through the origin can be proven to be a vector space. Just put it in this form and then take two arbitrary members, add them, see if they're still in the space and all that stuff, right? Okay? So, V is a subspace of R2. Or by R2 I mean the entire plane, right? Because it's a subset of R2, and it's a vector space. That's what makes something a subspace of another space. It's a subset of that space. It's all contained in that space, okay? And that space is a vector space itself, and so is the subspace, okay? Is a vector space in its own right. Make sense? Okay. And look also at y. If I do x plus 1y, it's no longer a subspace. And the fact that what that does is takes this line and moves it away from the origin. It's not on the origin, it's not a subspace anymore. And look at how the arrows, we did it. So, I mean, just, look at the videos from last time. There aren't that many. You probably get through in 15 minutes. I don't know how long-winded I got, maybe it's longer. Okay. Okay, does that make sense? Okay, well, let me just give you flavor. Okay, V equals the set of X, Y, Z, such that X equals 2Y, and Z equals 0. Now that's in three-dimensional space, right? So how do you visualize that? Well, don't know how much three-dimensional drawing you've done, but you're going to want to get somewhat adept at it before you get to Calculus 3, okay? Because there it gets kind of involved, okay? So here's X, here's Y, and here's Z, right? Now, if I want to graph down here just in the XY plane, I can graph this line, can't I? And it'll satisfy this because we're in the XY plane, right? Okay? So that just becomes the line where y equals 1/2 x. So if this is x equals 1 and this is y equals 2, there's a point on the line, right? Okay? And so is the origin, so that the line just looks kind of like this. Okay? So it's a line in the XY plane of R3. Okay? Okay, now what if I do this? Okay, how does that differ from this?